Hello everybody. So we have learned a little bit about inverse functions last Tuesday. So we have learned that the inverse functions have to have this definition, meaning that when f evaluated at -1 here, you got -5, and then when you evaluate g at -5, we get back the -1. So that's inverses, right? Inverses of each other. So we have seen that. And then do all functions have inverse? So the answer is no. So we're gonna have two conditions. So a function has to have two conditions for them to have an inverse. So number one, the condition is 1-to-1. Number two is onto. Okay, so we have learned 1-to-1 last Tuesday. So today we're gonna learn a little bit about onto. Okay, so onto function. Onto is a little bit complicated, so I'm just gonna explain the concept to you, but I'm not gonna ask you to prove this during the exam, just so that you can understand what's going on. So suppose that we have a function f, right? Function f of x. So we know that given a set here, we have x here, right? So this is called the domain. And then we have the function f. So this is gonna be mapped into another set called codomain. Okay, so inside here is f of x. So an onto function is that given any b here, any element in here, you can always find an element here, a, such that f of a equals to b. Okay? For any b in the codomain of f, there exists a in the domain of f such that such that f of a equals to b. Okay, so every element in the codomain is a function value. So that's onto. It's like the f is on to the codomain. Every element in codomain is a function value. So that's an onto function. So I'm not gonna ask this, but I'm gonna give you an example of a not onto function. Okay, so let's see an example. I'm gonna use another color. Okay, so this is not an onto function. Okay, so suppose that we have a function f of x is, let's say, the greatest integer, the ceiling here, right? The greatest integer that we have seen before. So this is not an onto function. Why? Because the domain of f is real numbers, right? And the codomain of f is maybe a real number, but not all element in the codomain is a function value. Okay, so let's see a counter example. A counter example. So if we choose, we follow here, okay, b. Let's say we choose b equals to 0.5, right? We cannot find, there is no a real numbers such that f of a equals to 0.5, right? Because the output is always going to be integer, and we have defined that the codomain is going to be real numbers. Okay, so if the codomain is integer, then we're good. So this is an example of a not onto function. Okay, a function f is onto if the range of f is equal to the codomain of f. So this is just to complete the definition. Okay, so we have so this is the conclusion. The conclusion is two functions f and g are inverses of each other if you take the composite f composed of g, of f composed g, and g composed with f equals to x. So we have seen this before, right? So now to the calculation part. Oops, where is that? Okay, so let's do the calculation. So if f, this is the example from the start, right? We have known already that this is 1-to-1, but how to show it? Okay, so the question is, if is f 3x minus 2 1-to-1? So remember the definition, right? Suppose that x1 not equals to x2, then we have f of x1 equals to 3x1 minus 2, f of x2 3x2 minus 2, right? So these two, because x1 is not equal to x2, therefore these are not equal. Okay, not equal to each other. Therefore f of x1 not equals to f of x2. By definition, f of x equals to 3x minus 2 is 1-to-1. Okay, next, find the inverse of f equals to 3x minus 2. We already know the answer, right? Because this is the example from before. But just to show you how we do the calculation. So we know from the definition that f composed of g x is gonna equal to x, right? Or we have g composed with f, x is gonna equal to x. So we're gonna use this. Okay, so we have f, we want to find g, right? Because g is the inverse of f. So use the example. F composed g x equals to x. So what's the definition? The definition is f of gx equals to x. So now we substitute gx in place of x here. We substitute x with gx. So we have 3gx minus 2 equals to x. So rearrange this. We have 3gx equals to x plus 2, and then gx equals to x plus 2 over 3, right? So this is the answer that we have seen from at the start of the slide. Okay, yep, that's easy, right, to find the inverse of f. That's all. Thank you.